Hey guys, welcome to chapter 5.4, solving equations with radicals. Remember, the radical is just the root sign. Sometimes it's a square root like here, sometimes it's a cube root, fourth root, fifth root. We still use that little radical sign. So when we solve equations with radicals, we all know that to get rid of a root, I'm going to end up squaring here, right? If I end up squaring a square root, it undoes their inverse operations. So it's super important to check my solution, because when I square stuff, I actually end up with changing the sign, right? So it's super important that we always go back to the original problem and check our solutions. So first thing we want to do when we solve an equation with a radical is to isolate the radical, right? And so that means I'm going to try to isolate the square root of x plus 1. So I'm going to subtract 3. And then I'm going to divide by 2. So that gets me the square root of x plus 1 equals 2. So now I've got my radical isolated, so now I just need to square both sides. So remember, if I square something that's being square rooted, I just get plain old x plus 1. And here I get 4. So if I solve for x there, I get x equals 3. Now I want to check my solution in my original problem. So let's see, is it true that this 2 times the square root of 3 plus 1 plus 3 equals 7? So I'm making sure that this ends up being a true statement. Well, we know the square root of 4 is 2, right? So it is indeed true that 4 plus 3 is 7. So I'm good with that. Put a box around. Okay guys, let's use our powers of extension here. If I have a cube root, to undo a cube root, I'm going to cube both sides. But first, I got to isolate the cube root. Sorry, this is the angle that my hand has trouble. So instead of squaring both sides here, I'm going to cube both sides. So if I cube something that's being cube rooted, that's an inverse operation, right? So I'm just going to end up with the 2x minus 9. And over here, I'm going to end up with 27. So that's 2x equals 36 and x equals 18. Okay, but before we accept that, we have to check x equals 18. So let's see. Is it true that the cube root of 2 times 18 minus 9 minus 1 equals 2? Well, 2 times 18 is 36, and 36 minus 9 is 27. So is it true that the cube root of 27 minus 1 equals 2? Well, the cube root of 27 is 3. So you may be thinking, Miss Brindley, they're always going to work. But that's not true, guys. When we get to example 3, you're going to see why that's the case. Okay, so square both sides on the first one, cube both sides on the second one. Let's take an application, a real-world application. The numbers aren't as pretty, but the process is exactly the same. So here we've got a formula that measures, there are two variables. There's the wind velocity, v. So if I look at my formula, v of p is the wind velocity, which is a function of the air pressure at the center of the hurricane. So they want me to estimate the air pressure when the wind velocity is 5.45 meters per second. So that means I'm going to take the 5.45 and put it in for v. And remember, v of p is just function notation. Okay, so numbers aren't going to be as pretty, but I'm going to do the same thing. I'm going to isolate the radical. And so that means I'm going to do divided by 6.3 And that's going to get me 0.865 equals the square root of 1013 minus p. Okay, so now we've got our square root isolated, so we can square both sides. Right? And that's going to get me 0.748 equals 1013 minus p. Right? And now I have myself a simple equation with, albeit not particularly nice, pretty numbers. Okay, so I end up with approximately 1012.25. Now that's negative, but it's equal to negative p. So I can assume that p here, if I divide both sides by -1, right, I end up with that. So there's your real life application. Okay guys, so notice all three of these that we've done, there's only been a variable, an x or a v or something, on one side. Right, so here we've got one variable up, and the first ones we just had an x on one side. Once I start spicing it up, I sometimes end up with x's on both sides. Same process, square both sides, however, it's going to be a little bit more complicated. So take a look at this. If I go to square both sides, I have to remember that when I square x plus 1, that's actually x plus 1 times x plus 1. Right? And if I square the square root here, I'm just left with 7x plus 15. So I have to remember I'm going to have to FOIL this. Right? And if I FOIL, I get x squared plus x plus 1. Right? So that, these x's combine. So I get x squared plus 2x plus 1. Okay guys, now we have ourselves a quadratic. In example 1 we had, and example 2 we just had an x to the first or a p to the first. So when I have a quadratic, if you remember, I want to get 0 on one side and then do a diamond. Okay, so just to get your brain warmed up here, if I do the diamond problem, it's two numbers that multiply to -14 and add to -5. And those two numbers are -7 and +2. So that means my factors are x minus 7 times x plus 2. And I can go right from the diamond to the factors because there's a 1 in front of that x squared. So I'm going to get two answers. However, I've got to check them. And here's where you're going to see why I need to check. So let's check in the original problem. Let's go back and check x equals 7. So 7 plus 1, is that equal to the square root of 7 times 7 plus 15? Well, we know 7 plus 1 is 8. And we know that this is 49 plus 15. So yes, indeed, the square root of 64 is +8, and we're good with x equals 7. Okay, here's where I'm gonna show you what happens. So what if I plug in x equals -2? Well, let's see, -2 plus 1, is that equal to the square root of 7 times -2 plus 15? Well, -2 plus 1 is -1. So actually, this is not true. The square root of 1 is 1, and so those are not equal. So I have to say, all right, well, x equals -2 did come out in my algebra. However, it's what we call an extraneous solution. It doesn't work in all versions of the problem, which means I have to exclude it. So that's why checking is important. Okay, guys, the next problem is definitely the hardest. And if you take a look at it, you'll see why. It's the hardest because there are two square roots, 1 on each side of the equation. So when I go to square both sides, I'm going to have myself a little bit of an algebraic challenge. I'm going to have the square root of x plus 2 plus 1 on this side and the square root of 3 minus x on this side. Now it's really tempting to just square everything individually. But we know from the problem we just did, when I square an entire side of the equation like this, it doesn't mean just square the individual terms, right? It means we're going to have to FOIL it. And this is the part where people groan, because what this means is the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. And this one, luckily, is nice and simple. Okay, so let's FOIL this. We're going to do it nice and slowly. The square root of x plus 2 times the square root of x plus 2 is just equal to x plus 2. So I'm going to label the steps. There's the f. The o is the outer terms. The square root of x plus 2 times 1 is just equal to the square root of x plus 2. Okay, now let's do the inners inside. 1 times the square root of x plus 2 is equal to the square root of x plus 2. And then the last one's the easiest, 1 times 1. Right, so there's what we have. We've got FOIL. Okay, so we have some like terms here. First, we can see that there's a 2 plus 1 I can do. And then I can also take the square root of x plus 2 and add it to the second square root of x plus 2. So if I do that, right, if you remember from the lesson 5.2, I can add these if they're like terms, and they are in fact like terms. So I can do the x plus 3 from doing the 2 plus 1, and if I add these, I end up with 2 times the square root of x plus 2. Okay, so now at least we only have one square root. So what we want to do is we want to isolate this. So let's subtract x. Let's subtract 3. And look what happens. Well, these go out, and I'm left with 2 times the square root of x plus 2. Well, 3 minus 3, that's out, and negative x minus x is negative 2x. Okay, guys, we're almost there with the x plus 2 isolated, square root of x plus 2 isolated. So what we end up with over here, sorry, just make sure you can see, is the square root of x plus 2 equals negative x. Okay, so now at least we only have one square root. So now we have to square both sides again. And that gets me x plus 2 equals, well, negative x squared becomes positive x squared. So we already just messed with a sign here. So I can tell I'm probably going to get one of my answers is not going to work. But the mystery is which answer is not going to work. Okay, so that's what we get when we get 0 on one side. So two numbers that multiply to negative 2 and add to negative 1. Those happen to be negative 2 and positive 1. So I get x minus 2 times x plus 1 equals 0. And two answers, x equals 2 and x equals negative 1. Okay, guys, let's check x equals 2. Back in the original problem. So I got to say, is the square root of 2 plus 2 plus 1 equal to the square root of 3 minus 2? Well, that is the square root of 4. What do you guys think? Is that true? No. 2 plus 1 does not equal 1. So sorry, x equals 2, you're out. We have high hopes for x equals negative 1. Let's check it out. Check x equals negative 1. back in the original problem. Okay? Well, this becomes square root of 1 plus 1. Is that equal to, now remember minus minus becomes plus. Ah, this one works. So we're happy with that one. So, sorry x equals 2, you're out. But x equals negative 1, that's good. Okay guys, one more of these. And then I'm actually going to make a second video with the inequalities. Because this is a lot for one video. Okay. Okay, the reason I included this third one is because it has a fraction exponent, which throws some people off. So it's x plus 30 to the 1/2 equals x. But if you remember, x plus 30 to the 1/2 is just the same thing as the square root of x plus 30. So let's do this. Now we have it written in more familiar form. We see a square root, so we're going to square both sides. And we're going to get x plus 30 equals x squared. Oh, there it is again, x squared. So I have to subtract x and subtract 30. So that's going to get me 0 equals x squared minus x minus 30. Okay guys, diamond. Two numbers that multiply to negative 30 and add to negative 1. Those would be negative 6 and positive 5. So this gives me 0 equals x minus 6 times x plus 5. And we end up with 2 answers. But remember, we gotta check them. So there's a bunch of books in front here, so I'm limited to where I can stand. Okay, let's see. Check x equals 6. Back in the original problem. Now I'm going to put it in the square root form. Just makes it a little easier to make sense of. Okay, let's see. What do you guys think? Square root of 36 does equal 6. Yay! X equals 6. We're good. What about negative 5, though? Well, let's see. The square root of negative 5 plus 30, is that equal to negative 5? Well, I'm hoping you guys see the problem already, the issue. When I take the square root of 25, it's the positive root. So 5 does not equal negative 5. So x equals negative 5, we've got to put a slash through it. Okay guys, I will be back for video 2 with inequalities.